Hello everyone, my name is Mohammed Haseeb. Today I'll present how Hadoop can be applied to analyze clickstream data in e-commerce. I'll begin with highlighting the business challenges, then explain why this problem is clear example of big data, and finally walk through the Hadoop architecture and workflow that solves these issues efficiently. In online retail, every click, every product view, and every cart interaction is logged. The challenge is that this information accumulates so quickly that traditional systems struggle to keep. As business, our goal and clear: provide smarter recommendations, reduce cart abandonment, and design better user journey without escapable framework. However, this goal remains difficult to achieve. This clearly is a big data problem because it fits the three verses. First is volume, millions of entries are generated daily. Secondly, velocity, data flow in real time as user interact with the site. The third variety, the data is mixed. Some is the structured like IDs and timestamps, while other parts like URL are semi-structured. Handling this mix requires distributed system, and that's where Hadoop comes in. Clickstream data is basically a record of everything a user does on a site. It includes which pages they visited, as what time and what action they took. By analyzing clickstream, businesses can predict purchases, design upselling opportunities, and map customer journeys. But the challenges are huge. Hadoop is an excellent fit for this type of workload. It scales horizontally, which means we can simply server to add more server to handle large data volumes. It protects data through replication, ensuring reliability. It runs on expensive hardware, making it cost efficient. Most importantly, Hadoop does not just store data, it also processes it efficiently, which is exactly what clickstream analysis requires. Hadoop architecture has three main layers. HDFS is the distributed storage system that splits files into blocks and spread them across servers. MapReduce is the computation framework that processes data in parallel. Yarn is the source manager that coordinates jobs across the duster. In practice, master nodes oversee everything: worker nodes stores and process data, and client nodes submit jobs. HDFS or Hadoop Distribution File System is designed for massive datasets in split files into fixed size blocks, usually 128 GB, and distributes them across servers. Each block is replicated to prevent data loss if server fails. This this setup allows parallel access to multiple blocks at once, speeding up process. It follows write once, read many modules, which is perfect for log data like click clickstream. MapReduce has three key steps. The map step converts log record into key value pairs like page A. The shuffle and sort setup group these pairs by key. All the records page A are together. Finally, the reduce step aggregates the results like calculating how many times page A was visited. This makes it possible to analyze huge clickstream dataset is structured way. Yarn is like Hadoop operating system. The source manager allocates CPU and memory across the cluster. Node managers monitor individual servers. Each each job has an application master that requests resource and coordinates execution. Finally, the actual tasks run inside the container, which are isolated environment that keeps job efficient and stable. The workflow starts when a user interacts with a website. Those actions are captured as logs. Tools like Flumes and Kafka send these logs into Hadoop. Inside HDFS, data is stored with replication of reliability, then MapReduce job managed by Yarn process the data. Finally, the results are passed to business applications like recommendation engines, and dashboard to improve customer experience. Thank you very much.